So, I'm Vinayak, and in this presentation, I'll be talking about how visualization system evolved from traditional single screen setup to immersive multi-screen environment. So, the idea behind this topic is the data becomes more complex, especially the geological data. We need better ways to visualize it. So, Liquid Galaxy is an open source system designed exactly for this purpose. And through the presentation, I'll using distributed architecture and coordinate controls across multiple machines and displays. So now we'll go to the agenda of the presentation. So the slide gives a clear structure of what will be covered. We'll begin with by understanding why single screen visualization is limited. Then we'll move forward to the Liquid Galaxy system overview and its multi-screen master slave architecture. After that, we will discuss synchronization and data flow, followed by the software stack and control mechanism. And finally, we will look at the real world use cases, challenges, and future scope, and then conclude with the summary. So, now we'll go to the next slide. So, why visualization needs to evolve? So, modern data set today are not simple anymore. We all know this. So, geological data in particular is large, multidimensional, and complex, and involving scale, depth, location, and time. So, the traditional single screen visualization restrict how much information we can understand at once. So users are forced to zoom in and out repeatedly, which means they either lose the context or lose the details. So immersive visualization system aims to match how humans naturally perceive space and wide continuous and contextual objects. So Liquid Galaxy was created specifically to address these visualization limitation. And then we have our fundamental limitation of single screen system. So single screen display provide very narrow field of view compared to the human vision. So when visualizing large maps and geological data, this become a major limitation. Zoom based navigation force user to constantly choose between seeing the big picture or the seeing details. So as the complexity increase, understanding relationship between region becomes harder. Collaboration also become limited when multiple users share the details on one screen. So as the complexity increases, understanding relationship between regions becomes harder. Collaboration also become limited when multiple users share one screen. So now we'll go to the next slide. Understanding immersive visualization. So immersive visualization takes a completely different approach. Instead of compressing information into a single display, it surrounds the user with the information. Multiple displays expand the visual field horizontally, same as the Liquid Galaxy. So, creating a panoramic experience, peripheral vision plays a key role here, helping user understand continuity even without focusing on every screen. And then navigation becomes smoother and user develop stronger awareness. This encourage natural exploration instead of constant zooming. Now we'll go to the next slide. Why multi-screen architecture are preferred? So multi-screen architecture preserve global context while still showing local details. Instead of scaling data down, information is distributed across multiple displays. Each display contribute to a single continuous panoramic view. Another major advantage is scalability. So basically the systems can grow simply by adding more screen. This approach align naturally with your geological visualization where continuity and relationship are critical. So now we'll go to the next slide. Liquid Galaxy. Now, in this slide, I'll give a high level overview about the Liquid Galaxy. So, we all know what Liquid Galaxy is, but still, I'll give a high level overview about what Liquid Galaxy in this slide. So, Liquid Galaxy is an open source immersive visualization platform designed mainly for spatial and geological data exploration. It uses multiple machines working together on a single system, and each machine control one physical display, and all display are synchronized. The result is panoramic visualization environment that feels continuous and immersive. So this setup allows user to experience data rather than just observe it. Now we'll go to the next slide, distributed architecture in Liquid Galaxy. So Liquid Galaxy follows a master slave architecture model. One machine acts as a master and coordinates the system. Multiple machines act as a slave node responsible for rendering. All communication happens over a local network. Responsibility are clearly separated, which improves performance, scalability, and stability. So now we'll go to the next slide, which is responsibilities of the master node. So the master node acts as a central decision making unit. It processes all user interaction such as zooming, panning, or rotation. So the master maintains the global camera state, which defines exactly what the system is viewing. And based on this, it sends synchronized command to all slave nodes. This ensures consistency across all entire display system. Now we'll go to the next slide, responsibility of the slave node. Each slave node controls one screen in the setup. It renders only a specific portion of the overall panoramic scene. So slave nodes receives command direct from the master node, and they do not compute global logical independently, but but the design allows fast and efficient parallel rendering. Now we have screen segmentation strategy. So the panoramic view is divided into horizontal segment. Each segment is mapped to the one physical display. The camera frustum is logically split across nodes. This prevents overlap or gap between screens. So as a result, visual continuity is preserved across all display. Next, we have the synchronization problem. So synchronization is one of the most critical challenge in multi-screen system. So all screen must update at the same time. Network latency can introduce visual delays, and even small synchronization errors immediately break the immersion. Camera drift can cause misalignment between displays. So now we have synchronization mechanism in Liquid Galaxy. So Liquid Galaxy solves this using a single authoritative camera state maintained by the master node, and all slave node rely on the shared camera configuration. Commands are broadcast with consistent timing. Rendering cycles are aligned across machines, and this ensures smooth and unified motion. And then we have our input and output data flow. So user interaction is captured through a control interface, and the input is translated into navigation commands are processed centrally by the master node, and then instructions are sent to each slave node renders its respective view segment. And then we have the architecture diagram here. So this diagram visually explains the entire data flow. So user input goes to the controller and then to the master node, and the master distribute the command to the slave nodes. Each slave node updates its display. Together the system behaves as one unified visualization environment. And then we have example data flow scenario. So basically when a user initiates a zoom in action, the master calculates the new camera parameters. These these updated parameters are transmitted to all the slave node. Each slave node update its viewport simultaneously to the user. So this appears as one smooth zoom action across all the screens. Now we'll see the software stack in Liquid Galaxy. So Ubuntu, we all know Ubuntu Linux provides the operating system base. Google Earth Pro handles geological rendering, and then Liquid Galaxy scripts manage coordination and automation, and SSH enables the secure remote command execution, and then KML files are used for camera and content control. Then we have next slide is our automation and control layer. So automation scripts, manual system control. So automation script reduces manual system control. Google Earth instances are launched programmatically. Synchronization is maintained automatically, and the system reliability improves significantly, and this layer is crucial for large installations. Then we have SSH based distributed control. So in this slide I will basically explain how SSH is used to control multiple machines in Liquid Galaxy from a single point, which is a key part of its distributed architecture. And so the command shows here ssh lg at the rate lg2 Google Earth Pro. So this command means that the master node is remotely connected to the slave node using SSH. So this command means that the master node is remotely connecting to a slave node using SSH. Here Liquid Galaxy is the username, LG is the username, and LG2 represent one of the slave node machines in the Liquid Galaxy cluster. So when this command is executed, the master node logs into the slave machine without manual intervention and directly start the Google Earth Pro on the machine. So this is possible because Liquid Galaxy uses passwordless SSH, which removes delay and user interaction during execution. The important point here is that the master node can trigger process on all slave nodes almost simultaneously, and instead of logging into each machine manually, the master sends command programmatically. Because these commands are executed at nearly at the same time across all the nodes, screen synchronization is maintained. So this allows centralized control over a distributed system, which is essential when managing multiple screens. So if I had to explain in short, so the SSH enables Liquid Galaxy to behave like one unified system, even though it is made up of many separate screens. So now we'll go to the next slide, the camera control using KML. So uh, so in this slide I'll explain about how KML is used to control the camera position and movement in Liquid Galaxy, so which is critical for synchronization for sure. So the code shown is this. So look at this is the block of a KML file. Now Now the KML block defines exactly how the camera should view a location. So longitude and latitude specify the geographic location the camera is focused on, and in this case the coordinates point to city Bangalore, and the range defines the distance of camera from the ground, which controls how zoomed in or zoom out to the view, and the tilt. The tilt specify the angle of camera, allows a 3D perspective instead of a flat top-down view, and heading defines the direction of the camera is facing, similar to compass direction. So the most important part is that the same KML configuration is shared across all slave nodes. This means every screen receives identical camera parameters. So because all nodes use the KML file, camera alignment remains perfect across all the panoramic displays. So this is a core mechanism behind synchronized navigation in Liquid Galaxy. So whenever the camera moves, rotates or zoom, all screen update together, creating a single smooth immersive visual experience using Liquid Galaxy. Then we have next slide, transition from single to multi-screen. So single screen system handles all rendering locally. Liquid Galaxy distribute rendering across multiple machines. Central coordination replace local only control, and then parallel rendering improves performance and scalability. So this transition enables immersive visualization. So then we have the key advantages of Liquid Galaxy. So Liquid Galaxy offers high level scalability by adding screens. It uses cost effective hardware, it uses open source and community driven, and it provides strong immersion and clarity. It supports collaborative environments. Then we will see the real world applications. So Liquid Galaxy used in education, urban planning, scientific research, museums and exhibition. So it enables immersive learning and analysis and data driven storytelling. So its flexibility makes it suitable for many domains. So it is very wide when it comes to the application. Now we will go to the next slide, which is our common technical challenges. So, common technical challenges include incorrect network configuration and IP mismatches, unsupported operating system, and software incompatibility can also cause this issue. So, most synchronization failures occurs due to the misconfiguration rather than the design flaw. So, while installing or while configuring your system, while configuring the Liquid Galaxy on your system, it's very important to configure with the right versions. So please do check out the Liquid Galaxy documentation before installing your Liquid Galaxy setup. Now we will see what contributors can learn. So contributor gain real world experience with distributed system. They learn network debugging and synchronization handling. They understand the importance of a specification. They also learn the open source collaboration practices. Now we'll go to the summary, and now we'll go to the summary and we'll try to understand what we have covered in the whole presentation through small points. So single screen system limit understanding. Liquid Galaxy enables panoramic immersive visualization. This is achieved through distributed architecture and synchronization. A deep understanding of the system benefits both users and contributors. Thank you everyone for your time and attention. So I'd be very happy to answer any questions. You are welcome to ask the question and please join further discussion on Discord. So yeah, thank you.